Hey, is that the new Apple Heart Rate Monitor watch?
Yeah, it is. I just got it. I love wearing it when I work out. It's great.
Yeah, I've been thinking about buying one.
Yeah, you should get one. Are you ready for a run?
Yeah, let's go.
Wow, it says my heart rate's at 130.
Wow, let me see. That's so cool. I wonder how it works.
Should we go find out?
Yeah, let's go. Heart rate monitors are devices used by athletes to aid their training, as well as doctors and cardiac patients as a way to judge their rehabilitation progress. It is important to monitor your heart rate while working out in order to maintain your target heart rate so that you do not over or undertrain.
The most common heart rate monitors used by athletes and the general public are optical heart rate monitors. The Apple Watch and other wrist fitness tracking devices are all optical heart rate monitors. The technology utilized in these heart rate monitors is photoplethysmography, or PPG. However, before I explain PPG, I want to first explain what is happening physiologically to produce this measurable signal. Heart rate is the number of times your heart beats per minute. Your heart is a muscle that works continuously, much like a pump. Each beat of your heart is set in motion by an electrical signal from within your heart muscle. The electrical activity is recorded by an electrocardiogram known as an EKG or ECG. Each beat of your heart begins with an electrical signal from the sinoatrial node, also known as the SA node. The SA node is located in your heart's right atrium. When your heart's right atrium is full with blood, the electrical signal spreads across the cells of your heart's right and left atria. This signal causes the atria to contract. This pumps blood through the open valves from the atria into both the ventricles. The P wave on the EKG marks the contraction of your heart's atria. The signal arrives at the atrioventricular, or AV node, near the ventricles. Here it is slowed for an instant to allow your heart's right and left ventricles to fill with blood. On an EKG, this interval is represented by the start of the line segment between the P and Q wave. The signal is released and moves next to the bundle of His located in your heart's ventricles. From the bundle of His, the signal fibers divide into left and right bundle branches through your heart's septum. On the EKG, this is represented by the Q wave. The signal leaves the left and right bundle branches through the Purkinje fibers that connect directly to the cells in the walls of your heart's ventricles. The signal spreads quickly across your heart's ventricles. As the signal spreads across the cells of the ventricle walls, both ventricles contract. On an EKG, the R wave marks the contraction of your heart's left ventricle. The S wave marks the contraction of your heart's right ventricle. As the signal passes, the walls of your heart's ventricles relax and await the next signal. On the EKG, the T wave marks the point at which your heart's ventricles are relaxing. Therefore, one cycle represents one heartbeat. The electrical activity can be recorded using an EKG, which consists of electrodes.
Currently, the most accurate way to monitor heart rate is through an EKG or electrocardiogram. This piece of equipment is what you would typically find in your doctor's office. By placing electrodes on the body, an EKG can measure the electrical activity within your heart and can give you a readout of your BPM, or beats per minute. Obviously, we can't take a machine this big with us when we go for a run, so what has been invented instead is a chest strap, which incorporates the same technology that the EKG uses but can be worn while doing exercise. Athletes are able to simply strap the device onto their chest, and it will work the same as the EKG at their doctor's office. Typically, these chest straps would be paired with an external wrist monitor so that you can get a digital readout. One thing to keep in mind, though, is that these are not perfect, as there is almost always interference from clothing, movement, and because it's a wireless technology.
Although chest strap monitors are more accurate than optical monitors because they directly measure electrical activity, optical heart rate monitors are more comfortable and convenient. That therefore brings us to optical heart rate monitors. Optical heart rate monitors do not measure electrical activity. Instead, they use the technology known as photoplethysmography.
PPG is based on the fact that blood reflects and absorbs a certain amount of light. Everyone is aware that blood is red because it reflects red light and absorbs green light. But what is interesting is that if you actually shine a specified amount of light, photons, into a body tissue and then measure the amount of light that is reflected back out, you can find out how much light has been absorbed by blood. Therefore, optical heart rate monitors using PPG technology are composed of transmitters, which emit green light, and receivers, which detect reflected green light. Transmitters, therefore, are the green LED lights found on the side of the watch that touches your wrist, and receivers are the light-sensitive photodiodes also found on the side of the watch that interfaces with your skin. Now, if you take that amount of absorption and graph it over time, you end up with a waveform, which is representative of the pulsatile changes in arterial blood in that tissue. Those changes in arterial blood volume correspond to your heart rate. When your heart beats, there is more blood flowing through the capillaries of your wrist, so the green light absorption is greater, and between beats, green light absorption is less. Therefore, by flashing LED lights hundreds of times per second, optical heart rate monitors can calculate the number of times the heart beats each minute. The benefits of these devices is that they are more comfortable than chest strap heart rate monitors and easier to wear. A few drawbacks of optical heart rate monitors is that they can be sensitive to changes in temperature and face the challenges of optical noise, skin tone variations, and low blood perfusion. However, if you are just interested in using an optical heart rate monitor for casual exercise, they are accurate enough to use and are just as accurate as chest strap heart rate monitors in most situations.